Okay, this is another problem where we're going to be wanting to use the fundamental counting principle. As we read the problem here, this pizza place, Giglio's. Pizza offers 3 types of crust. You can get thin, irregular, or thick crust. 3 types of sauce. You can get red, white, or a spicy red sauce. And a choice of either some, all, or maybe none of the toppings: pepperoni, ham, sausage, bacon, hamburger, onion, peppers, olives, pineapple, tomato, spinach, and buffalo chicken. We want to know how many different pizzas do they offer. First, I guess I'm a little disappointed they don't offer extra cheese, but I guess you need to take that up with the management. But as we try to solve this problem now, we have to remember that we try to take a problem like this and decompose it into the different decisions that we have to make. So think for a moment about what decisions you have to make, and decisions being, a finite number of choices for each decision, something easy to figure out. Now, a lot of people get hung up on, well, I could pick, how many toppings am I picking? Well, you could pick anywhere from 0 to however many toppings we have, which would be, I believe, 12. Ham, so we have 12 different toppings, so we could get anywhere from 0 to 12 toppings. But we don't want to approach it as what toppings that we pick. We want to approach it as a decision. And so we can first, hopefully everybody sees, you can decide on the type of crust. Right, we have 3 types of crust that we can decide on. So for the crust anyway, we have 3 choices for the crust. And we also have 3 choices for the sauce. Now, nothing in the problem indicates that it's a bad idea to get red sauce with the thick crust pizza or anything like that, so those things are independent. And then we approach each of the toppings by saying, okay, we can have the topping or we can not have the topping. And it's the best way to do this. There are some other ways, but it's a little bit more of an involved process. Best way is to look at each topping as a decision. Do I want that topping or not? If you're going to end up getting eventually, say, pepperoni, spinach, and buffalo chicken on your pizza, then you would have had to have answered yes to pepperoni, no to ham, no to sausage, no to bacon, no to hamburger, no to onion, no to peppers, no to olives, no to pineapple, no to tomato, yes to spinach, and yes to buffalo chicken. So we have 12 more decisions to make as we try to build our pizza. So we have 12 more decisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so then we approach each of those decisions and say, well, for each topping, we're either going to have it or not. So each topping has 2 choices, whether to be a part of the pizza that we're going to make or not be a part. And again, we're totaling up all the possible pizzas, so all of those things are independent of each other. And so now it's just a matter of multiplying all those numbers out. 3 times 3 times 2. Well, we got 12 twos, so you could write that as 2 to the 12th. And when you multiply that out, you should get 36,864. So we get 36,864. And that was just with 12 toppings, 3 different kinds of crust, and 3 different kinds of sauce. Now you can imagine a place that you get pizza from probably offers more than 12 different types of toppings. And maybe they offer more types of sauce and more types of crust. I don't know. It depends on the actual place. Now, it may be true, again, you might not want to eat some of those pizzas, but all we're trying to do is figure out how many possible ones are there. Okay? And also never mind about how long it's going to take to bake some of these pizzas with all these different toppings on. It's going to be 36,864 different pizzas. So you see how this power of choice really swells things up. We were only making choices that had 2 or 3 things that we could choose from, yet when we put them all together we have over 36,000 different outcomes.